Deep focus is the starting point for any effective studying because it determines whether your brain treats the information as something worth storing or something to ignore. When you sit down to study, your brain is constantly filtering inputs and deciding what matters. If your attention is scattered, that signal is weak, and very little of what you encounter gets encoded in a lasting way. But when your attention is fully directed at a single task, your brain shifts into a state that supports neuroplasticity, allowing real learning to occur. This state of focus is not just psychological, it's biological. When you concentrate intensely, certain neurochemicals like acetylcholine and norepinephrine are released. These chemicals sharpen neural activity and highlight the circuits involved in the task you're performing. In simple terms, they act like a spotlight, marking specific patterns in your brain as important and increasing the likelihood that those patterns will be strengthened and retained. Without that chemical support, information tends to remain shallow and is easily forgotten. One of the biggest obstacles to deep focus is distraction, especially from devices and multitasking. Every time you shift your attention, even briefly, your brain has to reorient itself. This constant switching reduces the depth of processing and interrupts the flow needed for strong encoding. It might feel like you're being productive when you juggle multiple things at once, but in reality, you're preventing your brain from entering the state required for meaningful learning. There's also a limit to how long deep focus can be sustained, especially in the beginning. For many people, it might only last 20 to 30 minutes before mental fatigue sets in. This is normal. What matters is not forcing yourself to sit for hours, but making sure that the time you do spend is of high quality. Short, intense periods of focus are far more effective than long sessions filled with distractions or low engagement. Training your ability to focus is similar to training a muscle. At first, your mind will wander frequently, and maintaining attention will feel effortful. Each time you notice your attention drifting and bring it back to the task, you strengthen the neural systems involved in concentration. Over time, this makes it easier to enter and sustain deep focus for longer periods. The environment you study in can either support or disrupt this process. A quiet, organized space with minimal distractions helps your brain associate that setting with focus. Even small changes, like putting your phone out of reach or using tools that block notifications, can significantly improve your ability to stay engaged. There's also a relationship between clarity and focus. When you know exactly what you're trying to learn or accomplish in a session, your brain can direct attention more efficiently. Vague goals lead to scattered attention, while specific targets create a clear path for your focus to follow. As you repeatedly enter this state of deep concentration, your brain becomes more efficient at activating it. Studying begins to feel less like a struggle and more like a controlled, intentional process where your attention works with you rather than against you. Active recall is one of the most effective ways to strengthen learning because it forces your brain to generate information rather than simply recognize it. When you reread notes or highlight text, the material feels familiar, and that familiarity can create the illusion that you understand it. But recognition is a low-effort process. It doesn't require your brain to rebuild the knowledge from memory, which is what actually creates strong and lasting neural connections. When you engage in active recall, you remove the support of the material and try to bring the information to mind on your own. This could mean answering questions without looking, summarizing a concept from memory, or trying to solve a problem without guidance. That act of retrieval is effortful, and that effort is exactly what drives learning. Your brain has to search for the correct pathways, activate them, and reconstruct the information, which strengthens those circuits each time you do it. There's a biological basis for this. During recall, the same neural networks that were involved in learning the material are reactivated. Each time those networks are used, they become more efficient and more strongly connected. Over time, this makes it easier to access the information quickly and accurately. In contrast, passive review doesn't consistently activate those networks in the same way, so the connections remain weaker. Another important aspect of active recall is that it reveals what you don't know. When you try to retrieve information and struggle or fail, you get immediate feedback about the gaps in your understanding. This is extremely valuable because it allows you to focus your efforts where they're needed most. Instead of spending equal time on everything, you can target the areas that are weak, making your study sessions more efficient. The difficulty you experience during recall is not a sign that learning is failing. It's a sign that learning is happening. When something feels challenging to remember, your brain is working harder, and that increased effort leads to stronger encoding. If recall feels too easy, it often means you're relying on short-term familiarity rather than building durable knowledge. Timing also plays a role in making active recall effective. When you space out your attempts to retrieve information, the process becomes more effortful, which further strengthens memory. Trying to recall something shortly after learning it is useful, but waiting longer and then successfully retrieving it creates a deeper level of retention. There's also a psychological shift that comes with using active recall regularly. You move from being a passive consumer of information to an active participant in the learning process. Instead of just taking in content, you're constantly testing, challenging, and reinforcing your understanding. Over time, this builds confidence as well as competence. You begin to trust your ability to access and use what you've learned because you've practiced doing exactly that rather than just recognizing it when it's in front of you. Making mistakes and correcting them quickly is one of the most efficient ways to strengthen learning because the brain is highly sensitive to errors. When you attempt to recall information or apply a concept and get it wrong, your brain detects a mismatch between what you expected and what actually happened. That mismatch creates a strong signal that something needs to be updated. And this signal is what drives meaningful change in neural circuits. This process is often referred to as error-based learning. Instead of viewing mistakes as failures, the brain treats them as valuable data. Each error highlights exactly where your understanding is incomplete or incorrect. When you then correct that mistake, especially right away, the brain strengthens the updated version of the information more effectively than if you had gotten it right from the start. The combination of error followed by correction creates a powerful learning event. Timing is critical here. The closer the correction is to the mistake, the stronger the effect on learning. When you quickly identify what went wrong and replace it with the correct information, your brain links the two together. This connection helps prevent the same mistake from happening again. If too much time passes, that link weakens and the opportunity for rapid improvement is reduced. There's also an important balance to maintain. If you make too few mistakes, your brain doesn't receive enough feedback to improve. But if you make too many mistakes without understanding them, learning can become confusing and inefficient. The optimal zone is where errors happen often enough to provide feedback, but not so often that you feel overwhelmed. This is sometimes described as working at the edge of your current ability, where the challenge is high but still manageable. Emotion can influence how effectively this process works. Many people feel frustrated or discouraged when they make mistakes, and that reaction can interfere with learning. When frustration becomes too intense, it can reduce focus and make it harder for the brain to process feedback. A more effective approach is to treat mistakes as neutral signals, simply information about what needs adjustment. This keeps your brain engaged and open to improvement. Another key factor is specificity. Not all mistakes are equally useful. Vague errors or repeated mistakes without reflection don't lead to much progress. What matters is identifying exactly what went wrong and making a targeted correction. This sharpens the learning process and ensures that the right neural pathways are being updated. Over time, this cycle of attempting, failing, and correcting becomes more efficient. Your brain starts to recognize patterns in your errors and adjust more quickly, sometimes even before the mistake fully occurs. This leads to smoother and more accurate performance, not because mistakes disappear. Spacing your study sessions over time changes how your brain stores and retrieves information, making learning more durable and flexible. When you study something once and then immediately repeat it multiple times in the same session, it can feel like you're improving surat. The material becomes easier to recognize and your performance seems to increase. But much of that improvement is temporary because it relies on short-term activation rather than long-term storage. When you introduce gaps between study sessions, your brain is forced to work differently. After some time has passed, the information is no longer sitting in your immediate awareness. To access it again, your brain has to reconstruct it, pulling from memory rather than simply recognizing it. This reconstruction process requires more effort, and that effort strengthens the neural pathways associated with the information. There's a useful principle at play here. The more effort it takes to retrieve something successfully, the stronger the memory becomes. This doesn't mean making things impossibly difficult, but it does mean allowing a level of challenge to exist. When you return to material and it feels slightly hard to recall, that's a sign your brain is engaging in the kind of processing that leads to long-term retention. Spacing also takes advantage of a natural process called forgetting. Forgetting is often seen as a problem, but in reality, it plays a role in strengthening memory. When you forget something partially and then successfully bring it back, your brain treats that as an important event. It reinforces the memory more strongly than if it had remained easily accessible the entire time. In this way, small amounts of forgetting actually improve learning. Another benefit of spacing is that it reduces mental fatigue and maintains the quality of attention. Long, continuous study sessions tend to lead to diminishing returns. As your focus declines, the effectiveness of each additional minute decreases. By breaking your study into shorter sessions spread over time, you ensure that each session is done with higher concentration and better engagement. Spacing also helps make your knowledge more adaptable. When you revisit material across different days and contexts, your brain doesn't tie that information to a single moment or environment. Instead, it builds a more flexible representation that can be accessed in various situations. This is especially important for applying knowledge in real-world settings, where conditions are rarely identical to how you first learned something. The timing of these intervals can change depending on how familiar you are with the material. Early on, shorter gaps help establish a foundation. As your understanding improves, longer gaps create more challenge and further strengthen retention. This gradual increase in spacing keeps the brain adapting instead of becoming comfortable. Over time, spacing transforms learning from something that fades quickly into something that becomes stable and reliable. Instead of constantly relearning the same material, you build a structure where each session reinforces the last, allowing knowledge to accumulate and remain accessible when you need it because your system becomes highly responsive to them. Spacing your study sessions over time changes how your brain stores and retrieves information, making learning more durable and flexible. When you study something once and then immediately repeat it multiple times in the same session, it can feel like you're improving basurat. The material becomes easier to recognize and your performance seems to increase. But much of that improvement is temporary because it relies on short-term activation rather than long-term storage. When you introduce gaps between study sessions, your brain is forced to work differently. After some time has passed, the information is no longer sitting in your immediate awareness. To access it again, your brain has to reconstruct it, pulling from memory rather than simply recognizing it. This reconstruction process requires more effort, and that effort strengthens the neural pathways associated with the information. There's a useful principle at play here. The more effort it takes to retrieve something successfully, the stronger the memory becomes. This doesn't mean making things impossibly difficult, but it does mean allowing a level of challenge to exist. When you return to material and it feels slightly hard to recall, that's a sign your brain is engaging in the kind of processing that leads to long-term retention. Spacing also takes advantage of a natural process called forgetting. Forgetting is often seen as a problem, but in reality, it plays a role in strengthening memory. When you forget something partially and then successfully bring it back, your brain treats that as an important event. It reinforces the memory more strongly than if it had remained easily accessible the entire time. In this way, small amounts of forgetting actually improve learning. Another benefit of spacing is that it reduces mental fatigue and maintains the quality of attention. Long, continuous study sessions tend to lead to diminishing returns. As your focus declines, the effectiveness of each additional minute decreases. By breaking your study into shorter sessions spread over time, you ensure that each session is done with higher concentration and better engagement. Spacing also helps make your knowledge more adaptable. When you revisit material across different days and contexts, your brain doesn't tie that information to a single moment or environment. Instead, it builds a more flexible representation that can be accessed in various situations. This is especially important for applying knowledge in real-world settings, where conditions are rarely identical to how you first learned something. The timing of these intervals can change depending on how familiar you are with the material. Early on, shorter gaps help establish a foundation. As your understanding improves, longer gaps create more challenge and further strengthen retention. This gradual increase in spacing keeps the brain adapting instead of becoming comfortable. Over time, spacing transforms learning from something that fades quickly into something that becomes stable and reliable. Instead of constantly relearning the same material, you build a structure where each session reinforces the last, allowing knowledge to accumulate and remain accessible when you need it. Sleep and rest are essential for turning studying into actual learning because the brain does not fully process information in real time. When you study, you are activating specific neural circuits, but those circuits are still unstable. They represent a kind of temporary trace that needs to be strengthened, organized, and integrated with existing knowledge. That deeper processing happens primarily during periods of rest, and most powerfully during sleep. During sleep, the brain shifts from taking in information to consolidating it. In certain stages of sleep, especially slow-wave sleep and REM sleep, patterns of neural activity that occurred during studying are replayed. This replay is not random. It selectively strengthens the circuits that were used and filters out less relevant information. It's as if the brain is practicing what you learned without your conscious involvement, reinforcing the pathways so they become more efficient and easier to access later. There's also a neurochemical environment during sleep that supports this process. Levels of certain neurotransmitters change in a way that favors memory consolidation. External input is reduced, allowing the brain to focus inward and organize recent experiences. Without this shift, the information you studied remains fragmented and more vulnerable to being forgotten. Even short periods of rest while awake can contribute to learning. After a focused study session, taking a brief break without engaging in heavy stimulation, such as scrolling on your phone or consuming new information, gives your brain space to process what you just did. These quiet moments help stabilize neural activity and improve retention on a smaller scale. Constantly pushing without breaks can overload the system and reduce the effectiveness of your study time. Sleep deprivation has a direct negative impact on learning. When you don't get enough sleep, the brain's ability to consolidate new information is significantly reduced. You may still be able to function and even perform tasks in the short term, but the long-term retention of what you studied is compromised. In some cases, lack of sleep can also interfere with attention and focus during study sessions, making it harder to encode information in the first place. There's also an interaction between how intensely you study and how much rest you need. Deep focused learning creates a stronger demand for recovery because more neural circuits are being activated and modified. The more effort you put into studying, the more important it becomes to give your brain time to stabilize those changes. Over time, consistent sleep and proper rest create a compounding effect. Each study session is not just an isolated event, but part of a larger cycle where effort and recovery work together. The brain becomes more efficient at storing and retrieving information, and learning starts to feel smoother and more reliable rather than effortful and inconsistent. Explaining or teaching what you learn is one of the most effective ways to turn information into something your brain can actually use. When you first study a concept, it often feels clear because you're seeing it in its original form, organized, structured, and explained for you. That creates a sense of familiarity, but familiarity is not the same as understanding. True understanding begins when you try to generate that same idea on your own without relying on the original source. When you attempt to explain something, your brain is forced to reconstruct the information from memory. It has to organize the idea, connect different parts, and express it in a way that makes sense. This process is far more demanding than simply reviewing notes, and that demand is what strengthens the neural pathways involved. Instead of passively recognizing information, you're actively building it, which leads to deeper and more durable learning. This process also exposes gaps in your understanding very quickly. You might start explaining a concept and suddenly realize that you're unsure about a key step or that certain parts don't connect as clearly as you thought. These moments are extremely valuable because they show you exactly where your knowledge is incomplete. Rather than reviewing everything again, you can focus specifically on those weak areas, making your study time more targeted and efficient. There's also a structural benefit to teaching. In order to explain something clearly, you have to simplify it. This doesn't mean removing important details, but organizing them into a coherent form. Your brain has to identify what is essential, what supports it, and how the pieces fit together. This restructuring strengthens your understanding and makes the information easier to recall and apply in different situations. Speaking or writing explanations engages multiple systems in the brain at once. When you talk through a concept, you activate language, motor, and auditory pathways simultaneously. This creates a richer and more interconnected memory trace compared to silent review. Writing has a similar effect, especially when you're generating ideas rather than copying them. The more systems involved, the stronger and more accessible the memory becomes. Another important aspect is that teaching naturally involves retrieval. You're pulling information out of memory repeatedly, which reinforces the neural circuits associated with it. Each time you successfully retrieve and explain a concept, those pathways become more efficient and easier to access in the future. This repeated retrieval is one of the key drivers of long-term retention. Over time, this habit shifts your role in the learning process. You're no longer just taking in information, you're actively testing, organizing, and refining it. The knowledge becomes more flexible, more connected, and easier to apply beyond the original context. As you continue to explain and teach what you learn, the quality of your understanding begins to change in a noticeable way. Information becomes easier to access, more organized, and more adaptable to new situations. Instead of relying on memory alone, you develop a deeper grasp of how ideas connect and function, which allows you to use them more effectively. Over time, this turns learning into an active process of building and refining knowledge rather than simply storing it.